The Lakehouse and AI are two titanic shifts in data space. And with them, it can feel like everything is changing beneath us. And frankly, that's because it kind of is. We have Iceberg, we have LLM agents, and so everything really is about to change. But as is so commonly the case with these idiomatic expressions, we shouldn't quite take them literally. There are some things that aren't going to change. Atoms are still atoms, and fundamentally data, and many of the challenges around it are still the same. Outside of those two, though, I can't actually really think of stuff that isn't changing. So I'll leave that for you to wrestle with. But my goal for this humble talk is to try to help you navigate what is and is not changing in the data world. Before I get too far ahead of myself, my name is Charles Jardina. I'm one of the founding engineers and VP of engineering at Airbyte. I've been working as a software engineer in the data space for over a decade. And at every job I've held, I've had to rebuild the same ELT pipelines over and over again. So my personal mission is to build ELT tooling so that the next generation of software engineers don't need to think about ELT anymore. Just like I don't have to spend all that much time thinking about assembly code, I don't think software engineers should be needing to spend a lot of time thinking about ELT. And so basically, I just love this stuff. I feel so lucky to be in the middle of this AI data revolution, and there's such a fascinating story to tell as this history unfolds. So speaking of history, I think this image is actually a bit of a misnomer because as much as AI and Iceberg are colliding, instead of being one of the major tragedies of the early 20th century, like the Titanic was, I think this is going to be one of the defining events of the 21st century. And so for the rest of the talk, we're going to be exploring what is and is not changing in the data world. And so we'll start off with an easy one. One thing that is not changing is that ELT is a better paradigm in the AI world than ETL. Airbyte has long preached this, so there's nothing new here, but the shape of AI workloads is only reinforcing this paradigm. The good news is that Iceberg has made it a whole lot easier to follow this paradigm. And so it's always nice when doing the right thing also becomes the easy thing. So as a refresher, ETL is sort of the original paradigm for data movement. In a world where disk was finite and not that cheap, extracting data and then transforming it in flight before loading it into the final destination made a lot of sense. Once disk became essentially free, though, ELT became especially more prominent, especially in the height of the modern data stack. And so this is the idea that you extract your data and modify it as little as possible before loading it into your data warehouse or data lake. After you've stored a raw copy of your data, then you go ahead and do transforms. Why would you want to do this? Well, it turns out extracting data is actually really expensive. And so there's a few drivers behind that expense. First, actually just moving the bytes and paying for the network and compute can really add up. And so really you want to put yourself in a position where you can decouple the extract and load, which you really want to do one time, from the transformation, which you might want to iterate on over time. Second, most data sources are slower than your data warehouse or data lake. Take an example, you're trying to pull all of your data out of MailChimp. If you're trying to pull it out of the API, the MailChimp API, that's going to be slower than if you have that data cached already in your data lake or data warehouse and it is ready for you to query. You throw things on top of that like rate limiting, and suddenly getting that data out of your API at a moment's notice is actually quite difficult. Finally, if data uptime and data availability is important to you, the best way to guarantee that is by storing that data near to where you're actually going to use it. Something that hasn't changed is that moving big data is still hard, both in terms of time and cost. Once you move it, you also never really want to move it again. And as data keeps getting bigger, that paradigm is only going to be more true. This is a problem that is sort of like easy to gloss over, so I want to walk through a toy example. Let's say you created a database table and you used integer as a primary key. You probably shouldn't have done that. You did. Once the table grows beyond 4 billion records or so, it's going to overflow that integer, and you're going to have to migrate your primary key column to be a big int or a UUID. If you've ever had to manage such a migration before, you know how painful it can be. Typically, you don't notice it's a problem until you've actually run out of integer space, and so that table is really already down. And then the migration takes a really long time to run because it's running on 4 billion records and can have negative effects on the rest of your database performance. And let's be real, the data we're talking about here isn't even that big. It still all fits on one disk. Once you start thinking of distributed systems, this problem compounds even further. So in the big data world, anything that makes you have to rewrite all of your data, it's a bad option. Iceberg fundamentally shifts this paradigm by separating storage and allowing you to query data in a logical schema without actually having to modify the underlying data. This eliminates the need for costly schema migrations and ensures that the data can evolve without disruption. So at least you get down to a place where you only have to move the data one time and then never again. All right, we're going to switch things up now. I'm going to start with what's actually changing first. Unstructured data and files, they weren't really a commonplace staple of the workloads of most data teams in the height of the modern data stack. Now with AI, everyone is processing these files and feeding them to LLMs because LLMs can actually do pretty interesting stuff with PDFs and media files. And so what's changing here is that whatever storage tool you need needs to be really good at storing files. The data warehouses have tended to have kind of limited support for this, and while they're catching up, it's still sort of an awkward interaction. Iceberg, on the other hand, is natively file first and allows you to store media and structured data together in a way that makes sense, rather than forcing some sort of artificial separation there. What is not changing is that even though we're talking about files instead of records, this data is only useful if your data operation actually has access to them. So it turns out we're going to just be doing this extract and load thing for a long time to come. It's not going anywhere. What is new on top of all of this unstructured data is that people want to do a lot more transforms. And in the world, SQL isn't really the choice for a lot of these transforms. And what these transforms are is evolving incredibly quickly. There's a lot of media to text, media to vectors, and the state of the art on that is changing incredibly quickly. What isn't changing is that you should extract your data and load it into your data warehouse in its raw form before doing any sort of transformations. And in fact, this focus on transformations pushes that paradigm even further, because as the state of the art changes, you are going to have to redo those transformations. Whenever vector representation you have of a document right now, it's going to look different in 6 months. And so 6 months from now, you're not going to want to have to re-pull all of that data from the data source in order to do that transformation. You want a copy of that cached in your data lake. And Iceberg is a really good option for that. Another significant change is the increasing prevalence of LLMs and AI agents as the consumers of your data instead of humans. What isn't changing, though, is for the agent to use that data properly. The data has to be there, it has to be correct, and it has to have all of its metadata with it. So that's things like permission, lineage, and any relevant documentation. Internal to Airbyte, we refer to this as the AI junior engineer principle, where just like when you're onboarding a junior engineer onto your team, they're going to have a much easier time if you have decent documentation and very clear conventions. The same is true when onboarding an AI into your code base or into your data. If you have the right documentation convention, it can onboard a lot more quickly and do much better work. Fundamentally, agents, while they feel like magic, they can't actually magic their way through broken and undocumented data. Agents can always be listening. They don't have to sleep as humans do. And so while human consumers sort of naturally think of data in terms of batches, since we check in on this stuff only ever so frequently, the agent can really benefit a lot from low latency data. That does not mean batch processing is going away. The same economics that have held true for the last decade for this stuff are still going to hold sway. Finally, agents are going to be responsible for doing a lot more analysis, and as part of it, they're going to need to build data pipelines themselves. What's not changing here is that in order to do that, the agent needs to work from the same canonical data set every time. Here's a snapshot of what I think this should look like. You pull data from all of your data silos to make, say, a customer table. So you're pulling from your application database, Clearbit, Salesforce, etc. This data needs to be curated because encoded in how you construct it are choices that are very specific to your business that it is going to be very hard for an LLM to make for you. You can definitely use an LLM to assist you on some of the grunt work or make suggestions. After you've built those core business tables, subsequent analysis can run on top of them. And so in this example, I have the AI agents coming in and we're asking them various questions, and they're relying on those core business tables, then building their own ephemeral data sets on top of that in order to answer questions. The key thing here is that all of these analyses can be trusted because they're all working from the same shared ontology, so that they're both comparable to each other and should be reproducible. What I hear people asking is that with agents, do we even need data lakes at all? Won't it all be ephemeral? And the answer, the data lake is actually even more important in this world. Because imagine a world without these business tables. The agent is going to, from scratch, try to take this raw data, join it together to make a notion of a customer, and then use data to answer your question. It might get lucky and cram this data together to make a reasonable notion of a customer. I would bet against it, but for sake of argument, let's say it does an okay job. The real problem is the next question you ask, some other agent is going to come in and it's going to have to build its own notion of customer. And so then you're going to end up with customer prime. In the example I have on the slide, the agent is being asked two different questions, but you can imagine just asking different agents the same question. The likelihood that they're going to come up with the same notion of a customer is incredibly unlikely. And so then at that moment, none of your analysis is going to be comparable across analyses, and you're going to lose reproducibility, which make that analysis, frankly, worse than useless. In order to get value out of these ephemeral data sets, they need to be built on well-defined core business tables. Otherwise, we're going to be in a world where agents can't even agree on what a customer is. Based on all of this, hopefully I've convinced you that the data lake plays a pivotal role in AI. I think the TLDR of this conversation is that everything is changing. Iceberg was a good paradigm shift before AI, and an even better one after. And with that, please go out and use these tools and go make history with them. Thank you.